The first three weeks, they're up here in Hawaii. Crazy things would happen in the middle of the night. New fissure would open. I would go out in the neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook to help people understand what's going on, get the questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhood sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live, still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. It was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea and the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption, and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is Volcano Education, and the other part is Digital Resilience, which we address through online groups on social media. So the way the two programs work together is that social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Ulu eruption in 2022. Within hours of that eruption starting, we had the Mayor Mitch Roth, we had USGS Ken on the stream trying to help flush out a little bit of ongoing. It's so new. It's completely different from our previous major eruption, 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out right here. Right. Our job is to get information to the public and make sure that the public gets it as well as possible and as correctly as possible. When Philip started coming to and live streaming the meeting, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip because they were more relaxed, and they were we were getting to the local community, and people were asking questions. So those were the best. I think I just want to give a shout out to those guys. And how we worked as a team on this eruption. It really worked out well. We got to a lot of people who wouldn't have gotten that.
Aloha everyone, and welcome to it today. This is July 3rd, and we're here with your Hawaii Volcano Tracker update. I'm joined by Mr. Lou Atori. How you doing there, Lou?
I'm doing good, Dane. Had a busy weekend, didn't we, up top?
Yes, we did. So, a lot of earthquakes up there. We still are not with Philip Ong, who is on leave right now, but he will be back next week. And today we do have a volcano summary from Phil that I'd like to jump right into, if that's all right.
Let's do it.
All right. Hey, Phil. All right.
Aloha, everyone. This is our Hawaiian Volcano Summary for July 3rd, 2024. It's been 1 month since Kilauea's most recent eruption, but the volcano has recharged quickly since then. As a result, over the final 4 days of June 2024, Kilauea's earthquake counts spiked with over 1,450 earthquakes in the summit region. These events began on the afternoon of June 27th with a 90-minute flurry on the Upper East Rift Connector, headlined by a magnitude 3.4, before resuming in earnest the next day. The earthquake rate further escalated on June 29, quote, reaching a peak of approximately 30 events per hour around midnight. The largest of these events were 4 magnitude 3.0 earthquakes that occurred near the intersection between Keanakākaoʻi Road and Hilina Pali Road in Hawaiʻi Volcanoes National Park, around depths of 1.4 to 3 kilometers, or 1 to 1.8 miles, according to the USGS Hawaiian Volcano Observatory. Status reports and daily updates. The next day, activity shifted marginally back toward the summit, focusing the area between Keanakākaoʻi and Koʻokoʻolau Craters, and featuring a magnitude 3.2 earthquake. By July 2nd, earthquake rates returned to the slightly elevated background rate present before the spike in activity. With a slight delay, ground tilt monitors paused their long-term inflation around the summit during a peak in activity on June 29th and 30th, but have since resumed their increase as earthquakes have quieted down. The Uikahuna signal is also recovering from recent maintenance. Over the past week, GPS stations have shown added uplift on the Upper East Rift Connector, continued uplift in the South Caldera, but a reversal to small-scale subsidence in the main caldera, and the Upper Southwest Rift Connector, uphill of its recent eruption site. Satellite radar imagery for the 2 weeks just prior to the onset of elevated seismicity show continued inflation in the South Caldera and along the trace of the June 3rd intrusion. Similar to the first week following the eruption, there's the first week and the eruption. Altogether, this is just magma ceased moving toward the recent eruption site around the same time as a new pulse of intrusion into the Upper East Rift Connector and Kauai Fault Zone. Enough to raise the ground by at least 1.5 inches or 4 centimeters at Devo's Throat, Puhimau, and Ahua within the past week. This returns Kilauea to the pattern exhibited before the recent eruption, with many starts and stops of elevated seismicity, pulses of intrusion in the South Caldera, Kauai, and Southwest Rift, and generally great swelling as magma supply to the volcano continues robustly. While similar activity in the past also grew to include eruptions in the Southeast Rift Connector and eventually the Middle East Rift Zone, for now there is no increased threat to people living near Kilauea's Lower East Rift. The greatest present hazard remains volcanic emissions, still within background rates at 75 tons of sulfur dioxide measured per day on June 28th, but sufficient to affect sensitive individuals nearby. The prognosis from USGS HVO remains that, quote, changes in the character and location of an arrest can occur quickly, as can a potential for eruption, but there are no signs of an imminent eruption at this time, unquote. Mauna Ulu remains quiet, continuing to recharge in a normal pattern with relatively few earthquakes and sustained slow inflation following its 22 eruption. That's the summary for this week. Mahalo.
There he was. Yeah. Thank you, Phil. And he will be rejoining us next week. It's kind of different with Phil, sending in the summary like that. Yeah, for sure. So what do you think? A lot of action up there, yeah? Yeah, it really did the same thing it did, a month ago or 2 weeks ago. We see 300 on the board. It's just going and going and going, and then fizzles off again. It's the point where the boots really aren't even getting put away, or we're ready to lace up. And one blink of an eye, and we go from 200 to down to 30. It's incredible. But like always, we keep watching. Oh, there's our video. Don't give them no spoilers yet. Yeah, that comes later. Mm-hmm. But since Phil recorded that update this morning, we got something published by USGS HVO, a volcano notice, where they go over basically what's been happening, and not much has changed since Phil's update, but they provide some new information, alternative to the morning updates, that's worth going into in a little bit more detail. So I'd like to read that a little bit here for you. So pit craters and lava flows on the upper East Rift Zone are evidence of a long history of magma moving along the Rift Zone pathway. Intrusions of new magma into this region have been monitored numerous times in the past decades with sparse eruptions. During the past 60 years, there have been approximately 50 intrusions and 5 eruptions in the upper East Rift Zone region. The last upper East Rift Zone eruption took place November 1979. That was a brief one-day eruption that occurred near the Puahi crater and was preceded by 2 months of increased earthquake activity along with inflation at the summit region. Several other Upper East Rift Zone eruptions took place in the early 1970s and lasted from 1 day to about a month. Upper East Rift Zone eruptions have typically occurred near the southeast margin of Kūlaupele, and Upper East Rift Zone meets the Middle East Rift Zone near Puahi crater. So this seismic unrest in the Upper East Rift Zone reflects higher levels of summit pressurization and does not necessarily indicate future unrest will continue or that eruption may occur in this region. So we've had seismic swarms up there before, including recent ones in May, but their forecast, they break it down into 4 possible scenarios. And one of them is that magma continues to accumulate beneath the Kilauea summit, resulting in intermittent periods of unrest with no immediate intrusion or eruption. So it kind of does what it's been doing, and we've been seeing it doing most of this year. And in this scenario, episodes of earthquakes and ground deformation will continue at varying rates at varying locations, including beneath the summit, the south summit, south of the caldera, and Upper East Rift Zone, maybe even the South Rift Zone as well, the southwest. So the other option 2, magma continues to accumulate beneath the Kilauea summit, resulting in an eventual intrusion, similar to what occurred in January, February of 2024, and the intrusion southwest of the caldera. In this scenario, we would expect to see accelerated rates of ground deformation and earthquakes in the direction of the intrusion as it occurs, along with summit deflation. And we have seen that, and that's going to continue for some of the other. So, option 3, magma continues to accumulate beneath the Kilauea summit, resulting in eventual eruption, summit eruption, similar to what occurred between the 2022 and 2023, the half dozen eruptions we had in there. In this scenario, we would expect to see signs of the magma reservoir beneath Holly Mountain rapidly pressurizing prior to accelerated rates of ground deformation and earthquakes beneath Kūlaupele and before lava reaches the surface. And then finally, the last option is it continues to accumulate beneath the summit, resulting in eventual eruption in the caldera, but within the general summit region, or outside of the caldera, sorry. So this is outside, but in the summit region, and it extends into the upper rift zones that we've been talking about, where all the seismicity has been taking place. And they'd expect earthquakes to migrate away from the summit following an accelerated rates of ground deformation and earthquakes before lava reaches the surface. So a couple different options there. It either continues to do what it does, it has an intrusion, it has an eruption in the caldera, or it has an eruption outside of the caldera, but still in the summit region. That's basically what we're looking at here.
Let me jump in here real quick, Dane. As you were reading all this, and this kind of goes to what we're going to be talking about and showing later on, but isn't really similar to everything that we kind of got lined up. All those different scenarios played out at one point in this whole area.
Go ahead and just tease it a little bit. We are going to be going back and looking at some restored footage from the Mauna Ulu eruption. So going back 1969, 74, and looking at that eruption, which had a lot of similar vibes to this. I was just reading a paper on Mauna Ulu from 69 to 71, and that first couple years and the 4 phases of the eruption that took place. But we're going to be diving into some video footage that we've used AI to restore, and that'll be coming up. But I want to jump back in here and just look at this progress that we've had. So let me scroll this out. This is pretty zoomed in. So we had we have 3 now INSAR images that have been given to us from the USGS, roughly the same area that we're looking at. So we have the first one, which shows right during the eruption and after the eruption, and the propagation of the dike and the new lava flows that happened a month ago now. And then we moved on to the June 6th to June 13th, so a few weeks ago now. And we see that inflation just south of the caldera and that upper southwest rift zone, that seismic southwest rift, whatever you want to call it, and extending down towards the eruption site. And we see multiple centimeters of change over the course of the 1 week period here. Finally, the newest one is from June 13th, taking off where the last one left off and going up to just about the end of the month. And we can see more inflation just south of the caldera region. It doesn't really show the east rift zone, but we're just focusing on that primary area of the inflation, which is still the southwest, the upper southwest rift, and the just south of the caldera itself. And USGS did get asked about, they spotted out about, somebody mentioned the earthquakes yesterday, and USGS said that the upper east rift zone tends to respond seismically to rapid summit inflation. The inflation stresses the area of the volcano with summit uplift of almost 1 centimeter a day over the past couple of weeks. It's no wonder there have been a lot of earthquakes. So it makes sense that summit, we've seen it on the tilt, and we see it as well on the GPS. Speaking of the tilt and the GPS, let's look at the GPS here. So looking up at the summit region, we can see that we have these vertical components showing inflation, as well as some trend changes that are somewhat interesting on the crater rim and the outlet in the last week, maybe, where it looks like it's shifted from moving east to moving west, potentially. But we see those also with some eruptions corresponding, some offsets that are in there. Into the east rift, we don't really got much going on at Mauna Ulu. There's some change further down the rift, looking at Pu'u'o. Really, we're not seeing these signals of inflation. All of this swelling at the summit extending far down the rift. But one of the interesting things is it seems like it's influencing the south flank, that further down, the south flank is moving and maybe at a somewhat accelerated pace there. So just wanted to highlight some of those. So there's a lot of movement happening up there. Yeah, and it is like similar to the scenario we saw in the lead up to the June eruption in May up at the East Rift Zone. And USGS has noted that this could transition. That window that we talk about, the eruption window, when eruption has the potential to happen, is open right now. Yeah, so just taking a look at some of the recent earthquakes, we can see over the past week here, those earthquake locations dominating down the East Rift Zone, the upper East Rift Zone, before the bend. That takes it further to the east. And this is also the area that we're going to, a little bit further uphill than what we're going to be talking about today. But it ties in. But lots of earthquakes over the past week. And these are, again, shallow earthquakes, mostly 1 to 2 kilometers down, roughly where the inflation's happening, where the magma chamber, the magma complex is, and all of the storage and all of the network that comes out of the summit. So there's a lot of magma in shallow areas, and it has the potential to erupt given a very short notice, as seen in the early June eruption. All right, so coming back to what the statement USGS put out today, they did include that there was some new web cameras that they released. The S1 camera, which has been repositioned, as well as the KO camera, which is on Mauna Ulu. And we'll just take a look at those real quick. We see the new camera location for the S1. And we do have a time lapse of the previous location. This was yesterday. So yesterday afternoon, you can see it was positioned and then it moves. And this is in the evening, so we get see a little bit of the sunset out over the southwest rift zone before nightfall and some stars out there. So yeah, very recent, the movement of that camera. And it's cool to see the update got put out today to highlight that. Looking at the camera that they deployed on Mauna Ulu, there was a camera on Mauna Ulu already, but this camera is looking to the northwest, whereas the other camera right here is looking to the northeast. So 2 cameras try and get that wide angle to be able to capture anything that were to happen further upslope from it. So trying to capture those, it's a challenge too. You only have a limited number of webcams to deploy. And their goal is just like everybody's goal that's probably watching the stream, is they want to see the eruption. They don't want to miss it with all the camera and the technology out there. So finding the best spot for your assets to at any given time, especially when you have multiple directions that it could go into the upper East Rift. It could go southwest again. We don't know. So they're trying to pick the optimal locations to potentially capture that activity. All right. So I just wanted to highlight where these cameras were. So this is on the USGS HVO website. And we come over here, we can see Mauna Ulu. Further to the right here is Pu'uo'o. Mauna Ulu, we have those 2 cameras, the KO and the MU. And the other cameras, S1 and S2. Whoops, I got to use this to zoom in. And then I get lost. There they are. So the S2, which didn't get moved, and the S1 that was moved yesterday. Just to show everybody where those are on the map. Zoom out. You can see most of Kilauea there. So yeah, new webcams.
Not an easy feat either. It should be noted to just go out and put up a camera. You know, there's boxes and batteries and wires and panels. I think that this one here, I didn't see it listed anywhere that they flew out and dropped it in. I know it's pretty typical for them to do that. But I thought I saw in one of the photos there was actually maybe a Jeep in the background. I don't know if you caught that or not.
A Jeep in the background.
Yeah, I thought I saw a vehicle. Like one of the cameras that they had put up, they drove to a certain point and walked in from there.
Interesting. No, I missed that.
We'll have to look. I think we have them on the slides tonight.
Oh, okay. All right. So last week I talked about the sulfur and gypsum depositing on the surface of the lava lake inside of the caldera, inside of Halemaumau. And Cosme was so generous as to put out a time lapse from Copernicus, the Sentinel-2 satellite, and showing the progression over the past couple years or the past year of all of this growth onto the surface of the recently erupted lava. Kind of cool to see it progress, huh? All right. Going back up to Kilauea and what USGS been up to. So they moved their webcam, but they also went up and recalibrated and adjusted the UWE tiltmeter. So the summit tiltmeter up by Jagger Museum nearby. And they re-leveled it. It was getting basically out of its threshold, and they needed to re-zero it, get everything adjusted. And this is their process to do so. So these are embedded down in the ground to be able to minimize impact on them from anything that's at the very surface. They're very sensitive instruments. And the first thing they have to do is remove all of the sand that they use to pad it at the bottom from the borehole. So they use a powerful shop vac essentially to pull all of that out. And they begin processing the levelings at the base of it, and they manually do all of this with they just sit there and manually get it until it's essentially zero by trial and error and experience. And once it's considered level, they put in this, they finish it off, but then it still requires a few weeks. There's maybe several weeks, they were saying, in order for this tiltmeter to go through the settling process and all of its information be true and genuine. They do note that it would still be useful for detecting something like a summit eruption. Those signals are big, but anything nuanced and small, there's an asterisk on it right now. But it's cool that they're out there recalibrating everything, making sure it's all working. And we see the tilt from UWE here, and we can see where they adjusted it. There's a lot less noise in the signal as well. So you see a little bit of the offset they mentioned would occur when they were doing it, but afterwards the signals has a lot less noise to it. So we'll be seeing that signal for a while. The last time they adjusted the tiltmeter was following the 2018 eruption. So it's been 6 years almost since this thing was re-leveled. USGS did go out into the Southwest Rift Zone, as we were talking about yesterday. They were out there, and this morning they posted some photography. This first one shows some of the cracks that have developed uprift of the June 3rd eruption site on the Southwest Rift. There's the vehicle I think Lou was talking about.
That's it right there. Yep.
Closer with all the cracks out there. So yeah, lots of cracks out there in that Southwest Rift Zone, just like this. And again, some of them get buried by tephra too. You can see that thin layer up there. Didn't get buried really, but kind of conceals it. We have sulfur deposits on the rocks. The note is that their sulfur deposits downwind of the cracks show southwest direction of the trade winds. These cracks are just uprift of the June 3rd eruption site, so more uprift, but closer to the eruption site than the previous photos. The one big difference that I see out here with this eruption and the sulfur is you don't have the weathering effects that you would see in the East Drift Zone because of the rain, and mostly the rain that would be happening daily, whereas Southwest Drift Zone, much drier. So you can get these wide deposits where it's a dusting of sulfur almost. But there's some thick sulfur deposits, some crystals, some sulfur crystals. These are pretty delicate little things. I've seen them in person, these following the 2018 eruption in large quantities, but they quickly deteriorated due to the weather after the SO2 emission subsided. So these are kind of temporary features. You get out there right after the eruption, they seem like they last a little bit longer on the Southwest Rift Zone potentially, though. But really cool to see. All the great photo here of all those details. So the new Southwest Rift Zone location, I think right over here is that berm that you see in the Southwest, the new S1 location. And they note that it's a new temporary webcam installed on Cone Peak, providing a better look at Kilauea's Southwest Rift Zone. And more sulfur and more cracks. While HVO geologists are moving temporary webcams, they revisited the site of the June 3rd eruption. This photo looks downrift with June 3rd pad of lava in the upper right. Extensive cracking uprift of the fissure had weak residual outgassing and vibrant sulfur deposits. Yeah, pretty cool there. So this is downrift looking back up. Or no, this is looking downrift. And I think we have community corner now, Lou. Do you want to take it away?
Good. There we go. All right. You're going to drop that slide back up on there?
Oh, okay.
There we go. All right. Thank you, everybody, for joining us tonight. First off, we'd like to thank Puna Strong and our Kilauea Recovery Grants that keeps us going, as well as all of you that donate to us, either here in Super Chats as well as on our website at hveri.org/donate. Can't do it without you guys. If you're just joining us, make sure you reach down there, hit that thumbs up. It does help out the algorithm boost that we desperately need at times. And I'm going to go ahead and play our credits here. There they go, right there. And our list keeps growing. I'm going to kind of let it extend for a little while longer, and then I'll give it another shot.
I think you're just back there practicing to get all the names right next time that you do it.
Don't give out my secret there. Some of those names I might have to rearrange. They're just not in the right order.
Right.
Yeah.
They have to flow off the tongue.
Mm-hmm. But donating to us on our website is definitely the best way to support us. hveri.org/donate. That will definitely do it.
Yeah, for two reasons. One, we get all of the donation revenue that comes through that way. Nothing goes to YouTube or Stripe, or less of it goes to Stripe. Right. But the other advantage is when it comes tax season, it's easier to write off a donation to a nonprofit directly than it is to a super chat that then goes to the nonprofit. So just throwing that out there. Appreciate everybody that tuned in today. We rely on viewers like you, really.
All right, I'm going to take us up to the park, and thank you to Yvonne, who hooked us up with some new shots of what's going on up there. And this is the work in progress. This is what they're doing, the renovations and the deconstruction and the reconstruction of the entrance. This is a pull-out. It looks like, maybe when I first saw this, I wasn't quite sure why. And then I thought, a lot of people pull over the side of the road when they get out of the park and figure out whether they're going to go right or left. So it's kind of a good idea. And it's only one lane coming out of the park. So it looks like they're extending the lane there. So that's our lane progress. That is a very congested area, especially when the cruise ship is in. So it really bogs everything down. You throw in a couple dozen tour vans and it's over. You're out on the highway. You can see just how small that area is up there. More lane progress. It's going to take them about 2 years to get this done. Give or take a storm, give or take an eruption. Anything can happen to slow us down up there. But at least we're seeing machines on the ground and work in progress. This is a lane off to the right when you pull into the park that you can go to the right and head into the visitor center direct instead of the way everybody goes now. Everybody goes straight into one direction to the volcano house, the visitor center, or make a left to head out to Chain of Craters. This might help a little bit. And this is just the express lane, they're calling it. And that's just the berm that's left over for the express lane. So thanks, Yvonne. Appreciate the photos. She's up in the park quite a bit and hooked us up with those. And we do have a press release that, again, it all kind of rolled right into our program today. It didn't really plan on it. It just kind of came together. Let me open it up here so I can read it full screen for you guys. This comes from Hawaiian Volcanoes National Park, and it says, Kilauea volcano is not erupting, but a sudden spike in earthquakes began over the weekend southeast of the summit in the vicinity of the Chain of Craters Road between Pumau and Luamaunu. Now, craters. Now, you guys all know that. That's all been in the summaries and everything all this week. But I'm going to come down a couple paragraphs, and I want to bring this up. It says there are no park closures related to the seismic swarm at this time. Temporary area closures could occur if seismicity increases. If an eruption occurs, visitors should expect the eruption site to close immediately while the park assesses if safe access is possible. Now, some others have seen this and emailed me and asked what that means. And the best advice I can give you, or the best answer I can give you to that, is when there is an eruption, check with the park before you go up, because they might close the front gate. They might get people out and assess. Even if it's in the caldera, we don't know. We don't know. This is them saying things that happen down on Chain of Craters, they do not want anybody down there. But
especially with the construction and there no parking and the visitor centers closing and all of these, like, it's stacked against them. And even when we were looking at the Mauna Ulu stuff, I was seeing evacuation, all of Chain of Craters Road evacuate with new activity. It's like, okay, so,
and it all makes sense, right?
New, but they're making their stance known right here.
And when you guys watch the Mauna Ulu video that we have, towards the latter part of it, you'll see a situation happen during an eruption where they only had a couple hours to get people into a safe location and make sure the area is clear. So I kind of agree that it's in their best interest to make sure people are safe. And so if you're going to the park, check to see if it's even open. The last thing we need is 75, 200 cars parked out on the highway. That's not any better than everybody trying to cram in the park. And if the park is open and you are unsure, pull into the visitor center and ask. The rangers are all knowledgeable. They'll have the best information on air quality right there. They're going to have, if you can get into the park, there's a pretty good chance they're going to have a safe viewing area. It just might not be where we thought it would be. It could change. We've seen them open, we've seen them close. So just check with the visitor center. And I think that was it on the update there from the press release. That is. All right. Thank you very much. That is our community corner.
All right. Oh. Yep. So that was interesting stuff going on up there, as always, or seemingly a lot of different moving parts happening at once.
Right.
So that's the national park. For next segment, I think we're going to just dive into that Mauna Ulu video, but a little bit of setup before we do. This video originally was published in 1979, Birth of a Mountain it's called, and it makes its date known immediately with the quality and the filming and a lot of different aspects.
The music.
Yeah, we wanted to try and clean it up as much as we could with the advancements in AI technology, mostly through CapCut and the features that are available there, just to enhance the video, enhance the audio, and try and give it a new feel for some old footage. So there's some differences, and I wanted to highlight how dramatically different it is. So I have a before with the original setup here and an after. Before we dive into it, just wanted to roll a few seconds of this.
As time went by, various methods of studying the Mauna Ulu eruption were put to use. There was too much happening at one time. Scientific teams were spread too thinly.
So a little bit of difference there, especially in the audio quality for me. So yeah, without further ado, I think we can dive right in. What do you think?
If you're a product of the 70s like I am, or before, you will appreciate this video because it will bring you back to shag carpets and colorful sofas.
Big heavy TVs and all of it.
Big heavy.
Of studying the
All right, so let's get that on screen here. Interesting. I'm not seeing it. Let me try and bring it up this way. There it is.
This is the Observatory. What's happening with Kilauea this morning? It's still inflating. Earthquakes are increasing. When is it going to erupt? Well, we can't say just when, but it could be soon.
Mark Twain once called Hawaii the loveliest fleet of islands that lies anchored in any ocean. Indeed, few places on Earth can match Hawaii's near-perfect climate and haunting beauty. But this warm and gentle land suffered at the peaks of huge volcanic mountains that for millions of years have erupted time and time again, building up from the sea floor to break through the ocean surface and form the islands we see today. At dawn on the morning of May 24th, 1969, the expected eruption was underway. A torrent of lava surged out of the smoke and steam. Men sent to observe that first eruption were met by a roaring curtain of fire. Scientists knew this eruption was coming. What they did not know was that lava would continue to gush from this site for the next 5 years. The face of Hawaii would be forever changed. This eruption was to be the birth of a mountain.
Name drop.
Observatory to vent. Go ahead, Observatory. What's happening down there?
The lava's about 10 meters down and rising. We're watching it.
Gotta love that audio. Oh, that's so
The
great.
Hawaiian Volcano Observatory, operated by the United States Geological Survey,
Look how much
is
the
perched on
screen
the rim
moves
of
in
the
this part.
caldera,
Yeah.
a
When I
large
look at the
crater
whole
at
metaphor,
Kilauea's summit.
right?
The scientists who work here
Before the
constantly probe
extensions.
the mysteries of volcanoes.
For the tower.
Kilauea lies in the southeastern part
There's
of
a
the
lot of
island of Hawaii.
stabilization happening. In this
Oh, yeah.
Stretching away from the
That's
summit
all
caldera is an area of frequent volcanic activity, the East Rift
I
Zone.
couldn't improve upon this.
The new
map if I
eruption
wanted to.
occurred about 8 kilometers from the summit,
way.
directly on the rift.
That is detail.
It's Microsoft Paint right there.
Kilauea has a long and varied history of eruptive activity. From within the caldera, Halemaumau constantly pours steam and gas into the sky. At the observatory, Seismographs were
And
recording
one
slight
time those
tremors
groups up
from
there
within
were
the volcano.
using that phone booth.
Magma, molten rock from the Earth's interior, was moving beneath the
Just saying.
surface and feeding the quiet eruption on the East Rift Zone. Gas was slowly rising through the lava. The escaping gas would sometimes push the lava up and over the rim of the vent, causing a large overflow. Day after day, men would walk up to the face of the red-hot flow to scoop out samples for laboratory study. They knew that lava fountains might resume at any time and shower them with a hailstorm of fire. Instruments called tiltmeters showed that Kilauea was inflating as magma from deep in the earth moved into reservoirs near the surface. This was an indication that more intense activity could occur.
Go ahead. This is Vent calling Observatory. It looks like a new episode is starting. We've got a good-sized fountain and a strong lava flow.
An important way to study an active volcano is up close in person. Teams of scientists
I'm sure that
headed
was
for the
live
vent
that
to
day.
study in detail this new active phase of the eruption. The volcano gave them plenty to do. Another episode of high fountaining was underway. 12 of these episodes occurred in 1969. At the foot of the fountain, in choking heat and gas, geologists continued their work, collecting lava samples, studying the eruption closely. This time, they saw a strange
So
phenomenon.
casual about it.
Lava
Look at the
rushing
volume
out of the
behind
main
to the
vent
side of him just coming
ran
out.
down to this lower
Not
vent
even 50
and
feet.
flowed back into
Now
the
that's
mountain.
some cool footage.
Possibly it was rejoining the inner rising stream of lava to be carried up
The only place
and
I've
once
seen that
again
footage is
erupt from the
over
main vent above. The volcano seemed to be recycling the molten lava. There were many periods of vigorous activity and relative calm. Day or night, the volcano was a spectacular sight.
Especially at night.
Scientists in the field studied portable seismographs locating earthquakes, trying to get some idea of where the magma below was moving. The activity continued, and there was more, much more to come. Millions of tons of lava gushed from the vent. Soon, the first searching fingers reached nearby Hawaiʻi crater. The volcano was beginning to drastically change the Hawaiian landscape. Hawaiʻi crater would soon cease to exist. Erupting lava is very hot and generally contains a great deal of gas.
Documentary.
The lava cools and the gas escapes as the flow travels farther from the point of eruption so that it thickens and moves more slowly. Hawaiʻi crater was close to the volcano's main vent, so the lava that reached it was still very fluid. A cascade of fire twice as high as Niagara Falls and 3 times as wide roared into the crater at a speed of nearly 50 kilometers per hour.
That's pretty insane.
At its peak, the lava fountain reached a height of 540 meters, taller than the Empire State Building. The tremendous heat from the river of lava generated strong winds. These winds created fiery tornadoes that whipped across the river, spraying flaming lava into the air. Every dawn saw not only a new day, but a new landscape. The volcano was earning a name, an identity all its own. Mauna Ulu, the growing mountain.
That's just the literal translation right there.
Just a little.
The lava trees.
Yeah.
Spectacular lava trees from that eruption.
In August,
Massive
a
amount.
Lai crater suddenly emptied of lava. Large cracks split open the crater floor and the lava drained back into the earth. In 2 months, Mauna Ulu would fill it again. 1970 saw Mauna Ulu entering a more gentle phase of the eruption. Scientists used the time to repair and renew equipment buried under previous lava flows.
And that's a pattern that repeats itself over and over here.
Yep.
Right? Eruption, bury equipment. Eruption, bury
Access to
roads.
the site was now
Repair,
more difficult as
rebuild.
roads were cut in a dozen different places.
It used to be faster to repair the
The
road.
scientist in charge of the Hawaiian Volcano Observatory, Donald Peterson, took to the air to survey the situation.
Echo, this is 412.
What can we do for you?
We have a car trapped on the highway. Can you see any way from up there of getting it out?
And then Batman shows up.
Oh,
Yeah.
no way.
What I was
It's
thinking.
totally surrounded.
Love
Looks
it.
like it's gone. Over and out.
The view from the helicopter might have been of a different planet. Barren, black fields of cooling lava stretched in every direction.
Incredible lava tree.
A
flow.
hardwood forest was now a grotesque forest of lava trees. These
Grotesque.
form when flowing lava sweeps around a living tree. Before the tree burns away, the lava cools, forming a mold around the tree trunk.
There are some clusters from 2018 that had some impressive
The
lava
hot
tree
gases
molds.
that escape
That's a
from
forest.
fumaroles carry
That's a
tiny
forest.
particles of various minerals, most commonly sulfur. As the gases rise into the atmosphere, they cool abruptly. The sulfur crystallizes and is deposited along the walls of the vent.
Basically Matt's photo from earlier.
His came up pretty good, but notice the similarities,
The
right?
island of Hawaii bears evidence of many past eruptions.
Very cracked.
On the southwest slope of the island is the Great
Talking
Crack,
about the same stuff.
another volcanic rift, probably
Yeah, between the
formed during a
southwest and
major
east.
eruption in the early 1820s. It is a vivid reminder of Hawaii's varied history.
Echo to observatory. Everything's quiet here. We're returning to base. Over.
Not for long.
As time went by, various methods of studying the Mauna Ulu eruption were put to use. There was too much happening at one time. Scientific teams were spread too thinly, but cameras could be where men could not. Metal boxes were fitted to protect
And that's
them
just the
from
original
heat
footage,
and
yeah.
falling ash.
All that flashing.
A lava shield such as Mauna Ulu grows by the piling up of lava flow after lava flow. Here is a time-lapse view of a day and a night in the life of Mauna Ulu. The lava pours out over the gently sloping sides of the shield. Another layer is added and the mountain grows, eventually to become the largest new volcanic landform in the United States in many centuries.
I just want to pause right there real quick. One of the differences between Mauna Ulu and 2018 was just the depositing of lava around the cone itself. Fissure 8 did not have the lava shield building at all. Its height was really gained by tephra and spatter. Traditional spatter cone with a bunch of tephra on top of it is essentially what Fissure 8 was. So it compressed and settled a bunch after the eruption, and it didn't get that tall. The majority of that lava was channeled out very efficiently all the way back to the ocean, several miles downriver. Mauna Ulu went through these shield buildings and created this huge profile, 1,000+ meters from the original landmass. So big profile compared to what we saw in 2018. M170 Jeep.
By mid-1972, Mauna Ulu had radically changed the face of the land, and the eruption continued. Now the lava was mostly traveling underground through lava tubes. Skylights in the tube ceilings gave scientists a unique opportunity to measure the temperature of the flowing lava.
It's hot, remember?
Yeah, it's hot.
It measures 1160 degrees Celsius. The top of this stream is cooling, forming a crust. When it hardens, it will cover and insulate the lava stream, so the lava will travel a greater distance before it cools and solidifies. To measure its speed, skylights along the stream are selected and, if necessary, enlarged. The ease with which these tubes can be broken open shows how fragile the crust is on which this man is standing. Two men are stationed at different points along the tube. They are in radio contact, and one has a stopwatch.
It's like, what kind of advanced thing are they going to use here?
Start your watch now.
What are
A
they
stick
throwing?
thrown into the lava
Stick.
bursts into flame and drifts downstream.
It's hot, very hot lava.
Got it.
The time the stick took to drift the distance between the men will give them the speed of the flow. Volcanic eruptions take a variety of forms. A fountain of lava shooting into the sky is only one of many types of eruption. Anytime molten lava can be seen or even heard moving on the Earth's surface, an eruption is taking place. This relatively calm phase of the Mauna Ulu eruption would soon turn into one of the most dramatic, as the red-hot lava splashed into the cold sea.
That original footage is really rough with that helicopter shake.
Pouring from the mouths of many lava tubes, the flow crept closer and closer to the shoreline.
They're about to show some footage I hadn't seen before.
Nothing could stand in its way.
Pretty cool.
These petroglyphs, carved perhaps hundreds of years ago by some of the earliest Hawaiians, vanished forever under the river of fire.
Interesting
The
too,
lava
because
reached farther and farther.
one of the oldest ways of preserving data is carving it into stone, and that just doesn't work in Hawaii. One, Kilauea is going to resurface 90% of it in the next 1,000 or so years, so it's probably going to get covered. But two, the island sinking afterwards, they're not going to last a tremendously long period of time, whereas something carved into granite or something like that in a more stable area would potentially. It's just part of Hawaii. That's just, sad to see, but how many times has that happened already?
Right.
From the main vent. 12, 13 kilometers. Large sections of lush forest in Hawaiian Volcanoes National Park were set aflame.
Observatory calling Echo. What is your present location? Are you in a position to observe the lava flow at the shoreline?
This is Echo calling Observatory. We're approaching Kaena Point now, and that flow that was way back has gone a long ways, and it's just reaching the ocean right now. Over.
Again, Mauna Ulu gave scientists a rare look at the forces that shape our planet. This is the process that built the Hawaiian Islands, and indeed much of our Earth's crust. For the moment, the ocean is fighting a losing battle.
I put my money
The
on
lava
ocean.
pours in faster than it can be washed away, and slowly the coastline pushes seaward. Gigantic amounts of energy are released in this head-on collision of fire and water. The battle went on, not only on the surface, but underwater as well.
Echo calling Observatory. The flow at the shore has greatly increased. There's a real good flow going on, and the divers have just gone into the water. They should be getting a real good show. Over.
The show that the divers captured on film was truly incredible. They recorded the sound and fury of an underwater lava flow. The hard crust above the tubes defies the breaking wave, and the lava continues to flow underneath the crust out into the ocean.
No gloves on.
Yeah, I mean,
At
even
great
if it's not hot, that
personal
stuff is
risk,
sharp.
the
Right
divers
there.
filmed
Yeah, it's sharp.
and collected samples of this strange and terrible fire under the sea.
That's so tough. Those guys.
Yeah, I miss watching that on the shoreline.
The sloping flank of the island extends down into the ocean, and the lava poured down this slope for many meters. Just beyond the perimeter of the lava flow, as though nothing at all was happening, life in the sea went on as usual. Lava continued to pour into the sea. Its source was the same vent that was supplying the lava lake in the large crater at Mauna Ulu's summit. The mountain had grown above the forest.
And they
when
had
in
underwater
May of
audio
1973, it underwent a dramatic change. The crater collapsed, the lava tubes dried up, and the flow into the sea stopped. Mauna Ulu remained sluggish for most of the rest of 1973, and some people thought it might be finished. It was not. Later in the year, activity resumed. By late January of 1974, Mauna Ulu was again erupting strongly. In the next few months, the mountain added another 30 meters to its height, and its shape was completely changed.
Year 5.
Lava fountains repeatedly roared into the sky in spectacular shows of fury. The United States Geological Survey and the National Park Service studied the situation closely and decided it was safe to allow tourists near the vent. People came by the thousands to see the terrible beauty of a volcanic eruption.
Should we go over that press release again?
On July 19th, the situation abruptly changed.
Park headquarters, this is Volcano Observatory. I have an urgent message. We recommend immediate evacuation of the Mauna Ulu area, the Chain of Craters Road, and Crater Rim Drive. The instruments are showing that eruptive activity is likely to increase soon.
Scientists were not sure how strong the impending increase would be, but they could take no chances. There was an urgent need for immediate evacuation.
This is 240, calling park headquarters. Go ahead, 240. I completed my sweep. Chain of Craters Road is clear.
Roger. Assist officers maintaining roadblock on Chain of Craters Road until further advised.
10-4.
The warning was issued just in time. 2 hours later, the eruption was underway. This time, the eruption was not at Mauna Ulu, but at Kilauea's summit caldera. Once again, a large section of Chain of Craters Road disappeared under the torrent of lava. Once again,
getting people out now,
moving lava rivers swept across the land.
It'll be tough.
Once again, they tore through the forests to leave only lava trees where living trees once stood. From July 19th to the 22nd, this eruption continued, then gradually came to an end. While the eruption at Kilauea's summit was dying, the last traces of the molten pool of lava in Mauna Ulu also disappeared. Mauna Ulu was silent, perhaps this time forever. No more lava poured from this crater that had been the center of such incredible drama for over 5 full years. The crater that gave birth to the newest mountain in the United States. This is an ever-changing world. No sooner had Mauna Ulu finished growing than the winds and rains began the process of erosion that will wear it away. But nature will take many thousands of years to level this mountain. A massive lava shield about 1.5 kilometers wide, 2 kilometers long, 130 meters high. Scientists hesitate to call the volcano dead. It may be dormant, only resting for a while.
Not a volcano. It's part of a volcano. And they don't rest.
Someday, Mauna Ulu, the growing mountain, might begin to grow once more.
I would bet against that and bet it would be right next door. Next door somewhere. Which is rare. So, Mauna Ulu, big deal. Huge eruption, 5 years.
Huge.
And back then, that was thought of as a very long eruption. And then 1984, we saw Pu'u'o begin its decades-long marathon of an eruption for 34 years. So now 5-year eruption doesn't seem that long, but really cool footage. We wanted to go back and highlight some of this stuff. We did do the restore on it, so you probably saw the anti-shaking that we had going on because the screen kept moving around. But once you watch the original, you go to that, you go to the stabilized version, you quickly adjust to the stabilized version, and it's just much easier on the eyes to watch, in my opinion, at least.
And the audio came out so much better.
Oh, so much
really
better.
cleaned up. Even with their 1970 walkie-talkies, it's still pretty good.
Every one of those walkie-talkie little scripted bits is hilarious to me.
Yeah, it's so
It's
great.
like,
It's so
you
typical.
imagine, especially back in the day, how HVO was, and then to have the scientists in charge, like, hey, can you read these little skid acts for me on the radio? I would be hesitant to ask, Ken Hahn to be like, hey, can you read these little, I am so impressed right now. Or
Yeah.
There's a
I hope
lava
I'm in
on
the
the
room
ground.
when you ask him. I thought that was a really good video, especially for the time. I grew up in a small country town, and they didn't have a lot, and this was a type of video that we would get at school. And I know we kind of poke fun at it a little bit now, but those were simple times when they just laid out pretty simple. Like, lava is very hot. For a small town country kid, don't really know about lava. That's probably the best way to put it in those times. I thought it was really well put together. I like how they also threw in the underwater footage. Just epic. Those guys, no gloves. I've
love how they
dove.
just go and smash a skylight in and then take a stick and throw it in there and grab a stopwatch, and that's the speed of the lava flow. And it's like, yeah, that's some volcano cowboy. Y'all guys earned that title back in those days. Like, just go out there and make it happen. You don't need no sophisticated LiDAR technology. Just give me do we have a stick nearby?
Right? I mean, that's it. Yeah. Even the cameras, look at the similarities, even the cameras then and today. Yeah, we have a little bit more high tech, and we're putting it through the internet so we can pick it up and monitor it wherever. But there's still just a camera in a metal box when it comes down to it.
All right. Well, speaking about a camera, we had a camera up with Phil during when we took up a group of students and took them around Mauna Ulu that I think you wanted to show a little bit of, huh?
Yeah, I did. It's funny that everything that we've done this last week, a little bit last week and this week to prepare for tonight, it's like we already had a lot of this stuff in place. And it was a few months ago that we were up on top of Mauna Ulu. I'm going to put this up on the stage.
And how secure it actually is in there.
And this is down on where the lava tree forest is, and Phil's about to talk about the lava bubbles that are on the ground right there. So I'm going to let Phil take it away.
The rock inside of the lava ball and how vesicular it actually is in there. So when its cracks are opening, it's not always a clean break. You're gonna have like some loose rocks in the middle that fall in or fall around, and sometimes those rocks will sink, and sometimes they'll just get rafted out and covered in lava. There's a lava ball. So this one's really cool because you can see it's actually broken in an angular fashion. Down here, I see the angular break of this rock. Right, this is not something that got formed in this eruption. It was like an old piece of rock that got cracked open and then got coated in this other lava. And it's oxidizing the inside as well, which is really what you'd expect. But that's the simple example of what could fall in lava and get covered up and make ball, right? So, there's more.
Those bubbles are everywhere. It seemed like everywhere I turned, there was another one round in the ground somewhere.
What do you guys see here?
Other cool things, right? Flow indicators. We know where the fish was right here in this case, but if you were like somewhere
Another thing I wanted to mention on here, you can see the lava bubbles out there in the background. But check out the ohia trees. There were some ohia trees out there that were 40 foot tall. That was 1970, so we're at 50 years ago. And these trees only grow 4 inches a year, 5 inches a year. They're slow growing trees, but they're all coming back. And Dane, you brought it up earlier about how like the sulfur deposits out there are still there because the rain isn't knocking them out. There isn't a lot of water in this area. I mean, their storms do come through, but those trees, they're just survivors. It's just a few shots that I took while we were there. There's the lava tree molds that are out there. This was the beginning of an 8 hour day, 8 hour hike, I think we did out there.
You did. I didn't do this.
Yeah, that I did. I think we rounded it. There's some more right there.
I found something else I needed to attend that day.
Of course you did. So one more, I think, coming up here. There we go. Now we're up top. So there's a shot of Mauna Ulu right there. This is one of the lookouts on the way up there. We diverted and went up the trail a bit to get this shot here. So we're about to hike up from this point. Go through a little bit of vegetation and then right into the thick of it. There's Phil telling everybody, stick to the trail, stick in a line, don't venture left and right because you're going to fall through somewhere. And there's the massive crater. The wind was howling. I wasn't getting too close. I was happy to have made it up there, but I wasn't going any closer than that. It's enormous. It's absolutely enormous. We circled the entire rim of it, and it was mesmerizing. You don't realize all the lava tubes like those right there, how many are up there. They're just everywhere. And Phil found a section that he really liked and started breaking it down and talking about the stalagmites, that the lava sickles, he called them, I think, up there. I'm going to pull up some shots here in a second. Still looking at the rim. You can see some people off to the right, and then that's a lava tube right there. Still up on top. We're still only 30 or 40 feet. I'm only 30 or 40 feet maybe from the rim. So there's Phil kind of talking about the way the lava comes down, came down through here. And as he's talking, I'm looking around, holding the camera pointing at him, but I'm looking around and I see the wall next to me. And that's when it all just kind of lit up. It's just the features. You can see some great shots from the helicopters, but unless you're on the ground there, you truly don't appreciate what the cooling lava builds, honestly.
Yeah, Mauna Ulu, Lance.
Mm-hmm.
Yeah,
Mauna Ulu, Lance.
Mauna Ulu. It's Mauna Ulu night over here. Yeah, really interesting stuff. Just do some questions while we're looking at this, huh?
Yeah, go for it.
Chuck asks, aloha guys, is there another access road if you are down by the ocean on Chain of Craters Road and if an eruption occurs? Nope, that's basically it down there. It goes in both directions, but that's your one road. Then that's not unique. There's many areas on the island where to get from one part of it to another, there's only one road that goes along the perimeter of the island. Just looking to see what else we got.
Yeah, there's another one in there about Mauna Ulu. Or no, it was Mauna Loa. There you
There's
go.
a question. Yeah, I'll throw that in there.
Oh, we keep clicking. Good.
Yeah, is the Mauna Loa at its maximum height possible? I mean, it's getting towards that end of height gaining phase that you could make that argument. But all it takes is, for it to gain any height is a little bit of spatter gets up on top of the caldera rim, and now you've added on the high point, and now you've added a little bit of height, right? So you can never rule it out, but Mauna Loa is a big, somewhat old volcano. Not as old as Mauna Kea, but yeah, Kilauea, though, it's going to continue to grow. It'll be come big one day. It'll be all grown up volcano.
All grown up.
And yeah, I think that basically does it. Thanks for everybody for jumping in on this special presentation and our update. We will be back to our normal time. This week we brought it to Wednesday because of July 4th. Wanted to get it out before then. And next week we'll be back at our normal time, which is Thursday, 5 p.m. Hawaii Standard Time. And we'll be joined again by the whole crew. We'll have Philip Ong back. We'll have Carrie and Dano back. And we'll be able to get back to our full production. And it's been fun, Lou. Thanks for joining me on these 3 streams. We had some fun. We did some AI things that we wouldn't normally do. We've been incorporating AI more and more and more. So it was fun to go back and revisit our AI art, which we put out the edited video of that yesterday in case you missed it. It's a cut down version of all the juicy bits from that presentation. And yeah, last week we did some drones on stuff, talked about 2018 eruption and this point in time 6 years ago. The activities going on there. And then we did Mauna Ulu this week, which just happened to align with all the activity and the press releases and the conversations that were being had. It all seemed to fit too well, so we had to do this.
The stars were aligned is what you're saying.
Right. It was meant to be on this one, just to find this video while we were doing all of our stuff and decide, like, hey, we know exactly how to restore that video. Let's do that and talk about it. It fits so well. Yeah. All right, everybody. I think that does it for me. We can go ahead and do our sign-offs, I think, unless you have anything else.
No, just thank everybody for joining us again tonight. Make sure you hit that thumbs up before you leave tonight. Thank you all who sponsor us or take care of us on the donation side, hveri.org/donate.
There you go.
And that's all I got.
All right. For Louatori, I'm Dane DuPont. Aloha, everyone.